All right, so we are going to start our first chapter in Pre-Calc, and the first chapter is all about functions. So the word function is something that you guys have heard a lot before, especially in Algebra 2, but we don't really know how to define a function. We don't know what a function is. We couldn't give examples or nothing like that. So that's what we will spend the next couple of weeks talking about, is what makes a function, how do we evaluate functions, and all that fun stuff. So today we're just going to do some basic notation and how do we evaluate functions. So you guys have all seen this lingo before. Remember, f of x is just another way we could just say that as y. F of x just means y. And like I said, we would say this as f of x. F of x. So f parentheses x just means f of x. This is the name of the function. So if I had g of x, this would be function g. Same thing if I had z of x, that would be function z. I could do the same thing with heart. So heart of x, this would be function heart. Well, we can name a function anything we wanted to. What is in the parentheses is what we are inputting into the function. So this is what I'm inputting. And then what it equals is my output, or you can think of it as the function rule as well. So another thing you can think is we are doing 3 times our input, whatever that might be, plus 1. All right, so like I said, today is going to be about evaluating functions. So here is our first examples. So we're doing g of x, so this is function g, is equal to our input squared plus 8 times our input minus 24, and we want to find each of these values. So the first one I want to find is g of 6. So my new input is going to be 6. So every time I see an x up here, I'm going to input a 6 in for that. This is going to end up being 6 squared plus 8 times 6 minus 24. And now I just have to follow PEMDAS and clean it up. So 6 squared is going to give me 36. 8 times 6 gives me 48. Add that all up and I believe we get 60. So g of 6 equals 60. And we're done. That is our answer right there. So if we input a 6 into our function, we're going to get an output of 60. People were asking me what I wanted to see for work here. I would expect you to show how you substituted or how you inputted our input into the function, and then I would expect to see the output as well. So these first and last steps. All right, we are going to do the same thing with negative 4x. So our new input is negative 4x. So I'm going to do the same thing. I'm going to have our input squared plus 8 times our input minus 24. So clean this up, we got to make sure that that 2 is going to both the negative 4 and the x. So this is going to become a 16x squared. And I have a negative 32x and negative 24. Notice I have no more like terms. There's nothing I can combine, so I'm done. I don't need to factor this or anything. When I plugged negative 4x in, I got that right there, and I'm done. All right, last one. This time my input is a binomial, but I'm going to do the same thing. So I'm going to have my input squared plus 8 times my input minus 24. And now we got to make sure we clean this up correctly. Earlier I saw people just distributing that 2 in there. But remember, because it's a binomial, I have two terms in there separated by addition. I need to actually copy paste that. So now when I distribute that out, I'm going to have a 25c squared. A 20c and a 20c gives me a 40c. And then a 16. And then I'm going to have a 40c plus 32. 32 minus 24. I can clean this one up, so I'm going to. When I clean it up, I'm going to have a 25c squared plus 80c plus 24, I believe. And again, I don't need to factor it. It's as cleaned up as I'm going to get. So g of 5c plus 4 is going to give me that answer right there. And I'm done with that one. Great. Alrighty. Okay, so notice this time I didn't give you any function rule or any output or anything like that. I just gave you a graph of f of x. And f of x is actually what we call a piecewise function. We have a ton of different pieces of function. So like here's a piece, here's a piece, here's a piece. So first thing they ask us to find is what is f of -2. So when our input is -2, when our x value is -2, what is our output, or what is our y value? So you can see at this case when x is -2, y is 4. Same thing with 0. So when I'm inputting a 0, what's my output? 0. I'm going to skip these ones for now, and I'm going to go to 3. When my input is a 3, my output is also a 3. Alright, I'm going to go back to these two. If you remember back to Algebra 2, when we have a closed circle, that value is included. You can think of it as like it's a greater than or equal to, or less than or equal to. When it's closed, it has an or equal to part of it. When it's open, it does not. So when it's open, it's either a greater than or a less than. When it's open, there's no equal piece to it. Okay, so when f of 1, when x is 1, our value is 1. This is the one that's included because it's closed. This one is not. So same type of reasoning over here. When my input is 2, my output is a 3. That is the closed one. Some people earlier asked me, well, what happens if I have two closed circles like that? And my simple answer for today, we'll learn more about this tomorrow, but if we have two closed circles like that, it would not be a function. So we wouldn't even have this conversation. The other question I got today is, well, what happens if they're both open? So then f of 1 would not exist. There wouldn't be an f of 1. It'd be in D and E. All right, last set then. So same directions. We are still dealing with a piecewise function. We're still dealing with pieces of 3 different types of functions. Now I'm just giving it to you algebraically. So this is saying when x's are less than -2, we're going to see the function x plus 3. When x is between -2 and 1, we're going to see the parabola x squared. And when x is greater than 1, we're going to see the line -x plus 2. So these are all of our domain restrictions. And then it's asking us to figure out what our function value will be when x equals -4. Another way you can think of that is, well, what is h of -4? So in order to do this, kind of like what we did earlier, we need to first figure out which 3 of this domain restriction -4 falls into. So is -4 less than -2? Is -4 between -2 and 1? or is negative 4 greater than 1? And hopefully you're picking the first one. Hopefully you're saying that negative 4 is less than negative 2. So, since it only fits this domain restriction, I can completely ignore those bottom two equations. And I'm just going to plug negative 4 in for x in the top one, because that's the one that it worked in. Clean it up, and I get h of negative 4 is negative 1. I'm going to do the same type of thing with negative 2. So is negative 2 less than negative 2? Is it between negative 2 and 1? Or is it greater than 1? And again, hopefully you're saying this middle one. Negative 2 is greater than or negative 2 is less than or equal to negative 2. So again, I'm going to ignore these the top and the bottom one. And I'm going to plug negative 2 in for the middle one, because that's the one it works in. Last time I checked, negative 2 squared was 4. Same thing. So 1 is greater than or equal to 1. So I'm going to ignore these top two. They don't exist for right now. And I'm going to plug 1 in for my x here. And I end up getting positive 1. All right, there's the lesson for today.